Hey everyone, it is me, Steve. It is March 25th, 2019. Time's about 16:47. It's 42 degrees Fahrenheit out. And it is Geo-Rant time. It's Geo-Rant 96. But before I get into it, I would like to say thank you to everyone. I hit 1,500 subscribers today. Thank you for that. I've already been remonetized a while ago. I think it's been a couple months now. Never received a check in my life. But anyway, what is today's Geo-Rant about? I am going to talk about compositional phase diagrams and Bones reaction series. All right. Actually, I was having a conversation with someone who collects rocks, and this came to mind because this is complicated. Mineralogy in general is really complicated, and if it's not your specialty, and it's not my specialty, it's a big pain in the butt. I basically know enough about mineralogy. I mean, I have some mineral compositions and crystal systems and that kind of stuff. The basics I do understand and I have memorized, but individual minerals, it's a mess. And groups of minerals, it can be a big mess. So I'm going to try to make this as simple as I can, and I'm going to use this book. This one is out. I wrote it. It's to identify igneous rocks. I actually used the proof when I was doing my identification of an igneous rock. I don't know, maybe a few weeks ago now. That was a two-parter. But what am I going to talk about today? Well, basically, I'm going to talk about this. And I'm going to show you the page of the book because I wrote it and I don't care. All right? We're going to talk about plagioclases and alkali feldspars and what you see down here. This is a compositional phase diagram. Okay? Now, according to Bones reaction series, as some of you may remember because I've ranted about this before, you have your discontinuous on the left here, your continuous series, and your residual series. I'm going to be addressing the continuous series here. Okay, that's this pink side. Basically what this is if a magma has all of the chemicals needed and it's hot enough, as it cools the continuous series here, what will happen is you will start with calcium-rich plagioclase. And as it cools, the calcium will be swapped out with sodium and potassium because that's more stable at lower temperatures, and then the calcium and potassium will go to other things, either here or the muscovite down here. Okay, that's how that works. All right, so basically what happens is plagioclase minerals will start to form, and then they will give up and they will become different plagioclase minerals. Plagioclase is not a mineral, it's a group of minerals. As a matter of fact, the only plagioclase minerals known, there are varieties, but varieties aren't their own minerals, is you have anorthosite, batonite, or bitonite, I always never pronounce that, labradorite, andesine, sorry, my bad, agiloclase, and albite. And every one of those plagioclases are triclinic. And as the magma cools, it will move from anorthosite to albite. Bitonite and labradorite, laboresce. They have that cool looking bluish green and a whiter, pale luster to them. Anyone who's messed with labradorite knows this. But there was a variety of albite. Now, these are all plagioclases, and albite is the end member. Albite's here. Albite is in the corner. You get your plagioclases going this way, and before they start becoming alkali feldspars going this way, they become albite. And albite has a variety, but it's not its own mineral, called peristerite. I'm sorry, I don't want to mispronounce it, so it's not a word I use all the time. Okay, all right. So, but it's rare, and that's what we were talking about because it's apparently this mine has some of it. Okay, so your magma starts to cool, and you move from here. Oh, and by the way, just so you know, TTGs, those rocks that are Archean, early Archean and older, alkali feldspars are non-existent. The earth didn't really make any true granites back then, but there's lots of plagioclase, and you'll even have rock types called anorthosite, which does not mean it's made of strictly of the mineral anorthite. Anorthite can be part of it, but so can labradorite and albite and any other plagioclase involved in this process. So what you have is you can see here. So you're going for plagioclase, and then eventually all your calcium's been used up by something else. So now your sodium's going to start to be replaced by potassium until you get to the top here, where you see at the top, you see two things. Technically, the end of the series is orthoclase, and that's what shows up here, okay? At the very bottom of your continuous series, which is the pink part, you'll see it says orthoclase. We're not going to talk about sandinine, all right? Just, no. Just leave that one out. Okay, so the thing about alkali feldspars is they are usually thought of to be monoclinic, but they can be triclinic. And a matter of fact, the triclinic form of orthoclase, since it's a different crystal system, means it's a different mineral, even though chemically it's exactly the same as orthoclase. See how annoying this is? It's called microcline, okay? And microcline is pretty common. And how do you tell plagioclases apart from alkali feldspars? Well, individual minerals are really hard to tell apart unless you have actual chemical analysis done on these rocks. They all pretty much have the same hardness, same streak color, stuff like that, you know, all the plagioclases. Unless you've got some sort of labradorescence going on, then you're pretty good bet that it's labradorite or bitonite. Like I said, the labradorescing version of albite is pretty rare. And alkali feldspars never do that. So if you see that, you know you have a plagioclase. Something else distinct about plagioclase is it has these striations, parallel striations that you are clear as day under a hand lens, okay? They stand out like a sore thumb, and I'm trying not to make this that long, but that's the blue here, okay? They are always parallel to one another, and they will form these parallel striations, all right? That is, those parallels, you see striations on a mineral like that, and on a feldspar, it's plagioclase. Except, of course, there's always an exception. Microcline, the triclinic version of orthoclase. I hope I got that right. Yes, I did. Microcline is a triclinic version of orthoclase, which is monoclinic. So triclinic microcline also forms striations, but they're distinct. They're not those parallel with the blue. That's what the yellow here is. The yellow is the microcline striations. Now you cannot rely on color. Usually alkali feldspars will be pinkish in color, and plagioclases will be whitish. But sodalite, I have uprolites where sodalite's like really blue. That's a void, but that's something, I'm just using it as an example to tell you that color doesn't tell you anything. Sodalite, its natural form is blue, even though it's not plagioclase. But in the uprolites, it looks like plagioclase. I mean, it's pink, it's white, so you got to be careful, okay? But it won't have striations like plagioclase will. So let's see, we're at 8 minutes, or almost 8.5 minutes right now. So to sum it up, okay, on Bones reaction series, as a magma cools, the calcium's going to get swapped for sodium and eventually for potassium as it reacts with stuff on the discontinuous series and eventually down in the residuals, like with muscovite. Okay, so if you have a lot of plagioclase, that means you had something that cooled. It was either a very potassium and sodium poor magma, okay, or it did, well, actually that's what it means essentially. I'm not going to get into anything more complicated than that, okay? So you got to be careful when you're looking at stuff. That cooling series has been well established now for almost 100 years through experimentation. So we know this is how that happens. And like I said, you cannot, you can tell if you have a plagioclase, and you can generally tell if you have an alkali feldspar, but you are going to have a real hard time trying to discern exactly what mineral that is unless someone has already done it in the area and knows it's there for sure. But anyway, I'm going to cut it off here before it hits 10 minutes. That's it. If you have any questions, leave them below. I hope you learned something, and I hope I didn't ramble too incoherently. All right.